brief introduction. So, like I said, I direct the Center for Sustainable Building Research at the university, and a bit of context. We do a lot of work for the state of Minnesota. We run the state of Minnesota's green building program for them for state-funded construction. So, because of that, we get involved in a lot of policy research, policy advice for kind of anything related to the built environment. So that's kind of the work that we're going to cover today. The other thing I'll just mention for this group, based upon the introductions, we also, because of our work integrating resilience into our standards in Minnesota, I'm also part of the ASHRAE 189 effort to update that standard that's focused on sustainability now, but is looking to integrate resilience into that particular standard. So that might be a thing to talk about in the future. So we've got three parts. Ariane's going to start and talk about the genesis of some of this work with a scan of how future climate data is used kind of in the built environment. It'll take maybe 4 or 5 minutes. Then Amanda will talk about the other bit of foundational work to our work, which is the work of the Minnesota Climate Adaptation Partnership and kind of our approach to downscaling data and using it across different use cases. And then I'll get into some work that we just did a legislative report to the state on the use of this data going forward for kind of infrastructure planning, but that's a subset of a whole bunch of work we're kind of doing in this space. So, and Ariane and Amanda, I'll advance slides for you if you just say next slide. So, Ariane.
Yeah, perfect. So we just wanted to introduce a white paper based on a research study that we did in collaboration with the Minnesota Climate Adaptation Partnership. I just dropped the link to the whole white paper in the chat. If you go to the next slide, this research was really coming out of something that we were seeing as a big disconnect between standard practice. This graphic, of course, is really prioritizing typical meteorological year files, which are used in energy modeling and other early sustainability analysis tools. And we were concerned by the disconnect between the TMY3 timeframe and what we are seeing in the new lifespan of the future, and thought by working with MCAP, we could really understand across the industry, the architecture, engineering, sustainability consultants, folks who work in the built environment, who was using projection data or information and really build a case for greater collaboration to solve some of the challenges we were seeing. So you can go to the next slide. So we did a 3-part study in 2022. Starting with a literature review, we did an online survey, which we distributed through many of the professional associations and other organizations like USGBC. And then we did focus groups with people who said they were using climate projection data or information. So organizations' primary function, most were architecture and engineering firms, though we did have some that were engineering-led, and then a couple of other examples of types of companies. If you go to the next slide, organization size ranged quite widely, and I will also say that we had a pretty good geographic distribution across the United States with a couple of outliers outside of the US as well. You can go to the next slide. The respondents' role in their day-to-day was primarily architects and designers. We had some sustainability specialists. And we also are hypothesizing through some of our results that this study represented a bias towards professionals who were already thinking about climate projection data or information, even though the overwhelming majority of them said they were not yet using that information in their practice because of the invitation to take a survey talking about climate projection data use in the built environment. We suspect this is not representative of the industry as a whole, like we might have seen if it was more generally worded. You can go to the next slide. So we had our findings in 4 key buckets. The first was that a lot of these professionals are offering sustainable design services focused on climate change mitigation, but that did not necessarily include considering climate projections and climate changes. So that was the first bucket. And then the second was that very few companies, firms, and consultants are regularly using projection data or information to inform their design decisions. Then the third was that there were a lot of barriers explaining why we were finding number two, including a lot of people said, well, our clients aren't asking for it. The data gaps, the process gaps, there were claims of liability concerns. If the standard of care says we do one thing and we do something else, are we liable for that if we're wrong? And then lack of expertise, knowing what to do with the data when we get it. And then finally, a lot is needed to help fill these gaps, codes, standards, training. It's very exciting to hear all of your introductions because I think this is a group working on a lot of these things. And now finally, the key findings, you can go to the next slide. Key recommendations. We had recommendations for each of these audiences, and I just pulled one example recommendation from each of them. But the conclusion of this research was that it's really needed for us to come together across sectors, have these boundary spanners like MCAP, climate data providers, associations, codes bodies, all working together. Because while our literature review found that there were a lot of people trying to tackle components of this challenge, we were not finding a ton of published examples of solutions that were based on those intersections across groups. And now it's been exciting to see how much work has progressed since. And so Amanda will talk a little bit more about MCAP, and then you'll hear more from Richard on what we've been doing in Minnesota.
Great, thanks, Ariane. As I mentioned earlier, I'm Amanda Farris. I'm an associate director at the University of Minnesota's Climate Adaptation Partnership. Next slide, Richard. So MCAP is a joint program of both the University of Minnesota Extension as well as the College of Food, Agricultural, and Natural Resource Sciences. I'm really focused on preparing and adapting for future climate conditions, and we're working to marry that idea of climate services with the power of extension on the landscape. So delivering sectorally specific expertise, utilizing research-based education and technical assistance, and then partnering across sectors and scales. So we have extension educators with different types of sectoral and disciplinary expertise, as well as researchers on our team, so that we're doing both that research-based science and education and providing the hands-on technical assistance and marrying those two things. So Richard, next slide. One of the foundational elements of our work is this downscale climate data set that we've developed that's publicly available through the Minnesota Climate Mapping and Analysis tool. The link is there, app.climate.umin.edu. That's really been pivotal to the work that we've been doing with CSBR and HGA. So I just wanted to give some background on what these data entail, and then Richard can go into how they're being used for the work that we've been doing in collaboration with CSBR and HGA. So Richard, next slide. So MinClimate provides 3 different emission scenarios. We've got SSP 245, 370, and 585. So we've got a range of different future possible scenarios in the tool. Go next slide, please. We also, next one. Sorry, I meant to skip that one.
No, no worries.
No problem. We also have 3 multiple timescales. We've got mid-century projections, late century, and end of century. So we really are looking not only at different future climate scenarios, but also as we think about the lifespan of some of this infrastructure in the built environment and the systems that we need in place for them to withstand conditions at these different time steps in future. You can also look at variables at the annual growing season, individual seasons, or at the monthly scale, depending on the type of variable that you're looking at. Next slide. And we've got over 30 variables in the tool that are publicly available. We've got different precipitation thresholds, including specific number of days with precipitation greater than basically measurable rainfall 1 and 2 inches. We have some drought information in there with longest dry spell, as well as maximum 1 to 7 day total precipitation. And we include snow cover depth as well, in the number of days with snow cover depth at these different 1 inch and 6 inch thresholds. I realize I was remiss in indicating that these projections are specific to the state of Minnesota. We do have some coverage in adjacent states just because of the dynamically downscale projections that were developed, but it's primarily focused on Minnesota with the tool. Our temperature projections include, again, these different thresholds that could be relevant for different sectors and different use case and decision making, with daily maximum, average, and minimums. and number of days that exceed these different thresholds, including 90, 95, and 100 degrees Fahrenheit. And the tool includes relative humidity as well. Next slide. We have soil temperature at 4 different depths, as well as soil moisture. And the downscaling that we have done incorporates 6 CMIP6 global climate models. They were dynamically downscaled with the WRF model, but they incorporate a lake model as well, so that we can provide projections about the proportion of lake surface that's frozen, as well as lake bottom temperatures. Next slide. And we're using these climate projections to inform a variety of different types of decisions. We're conducting professional training workshops. Through our extension education programs, we've developed some regionally specific climate summaries that not only draw the data from the tool, but also marry those with the impacts that different sectors and regions will experience based on future climate conditions. We're highlighting climate data case studies where folks are using these future climate projections to make informed decisions around design or management of resources, and we're providing that hands-on technical support and collaboration like the one that we have with CSBR and HGA. So I'll turn it over to Richard now, I believe, to talk a little bit more about the project.
Yeah, so the project we're going to focus on today is kind of a subset of our, long story short, our legislature's capital investment committee does tours of completed projects every summer and fall. And starting about 4 or 5 years ago, they started touring recently completed bond projects. These are building projects, roadway projects, wastewater treatment plants, those kinds of things. And in their tour of these projects, they started to see recently completed projects already damaged because future weather wasn't taken into account in the design of those systems. So they kind of came back and did a WTF moment of, this is unacceptable. We need to change the guidelines of how we do these things. And so that has rolled out in a few different reports and requests. One is to integrate resilience into our sustainability guidelines for buildings. So we're not going to have 2 separate standards. There's going to be integrated into one, which I think is a good move. And then this report, which, the research team kind of focusing on this, we sort of talked about it as the Distill the Ocean research report, because they asked us to think about future weather trends and its influence on all aspects of infrastructure and natural systems that sort of interact with infrastructure, which is a way too complicated question to answer with the very limited funding that we were given. So the challenge was to sort of look at future weather trends. There's a built environment portion kind of focused on that, but then it's a multi-sector request on infrastructure supporting, things that we want to do as a state, but how does that interact with forest systems, agriculture systems, natural habitat, et cetera, et cetera. So that's the work that we did. The other challenge that we had here is we have a very fungible definition of what infrastructure is in Minnesota. I'm sure we're not alone in that. So we had to create a working definition of infrastructure, which is, it's all built and intentionally used ecological systems that support, society's needs, basically, so that we are including kind of green infrastructure or even preserving a forest because of its effects on the watershed as an infrastructure system. So it's important to kind of keep that in mind as I go through these things. And then we had infrastructure sector specific definitions as well. All the work was kind of based upon the work that MCAP does, and I think one of the results of this work is that we looked at both energy and water usage, and the more finer grain kind of 2.5 mile resolution that we get from some of the MCAP downscale data really has some advantages as we see it kind of playing out across the state, across the seasons. So, another thing that became important for us is a lot of times we see sort of temperature data or precipitation data sort of averaged over the whole year. and at a pretty high level of granularity when we see it on the landscape. This is an example of one of the visualizations where we're showing increased temperatures for the 585 emission scenario end of century by season and at that finer resolution. And you can see even in Minnesota, we have kind of regional definitions that or differences that are playing out. And the same goes for precipitation that, when you see it by season, we have kind of increased rainfall in some seasons, particularly the spring, particularly in around the metro area, followed by droughts in the summer and kind of mixed falls, if you will. And it's important to understand those differences as we're setting design guidelines around the state. And this is sort of a subset of the overall kind of future weather shifts that we see in the Midwest that are affecting water supply and temperature in cities and all those kinds of things. And I think another thing that's a bit unique in the Midwest is a lot of our cities are in close approximation to large agriculture and forest areas. So the interplay between sort of natural systems and urban infrastructure systems is a little more closer and tightly knit than potentially other parts of the country. So in the work, we started to organize things and to kind of look at organizing, kind of understanding infrastructure systems using a social, ecological, technical kind of organization tool to think about, what's the societal need served by that system, what's its effect on the ecological systems, and then therefore what's the role of technology. We created a kind of planning framework by which policymakers could use this process to kind of understand an integrated approach across these systems for planning the way that we do infrastructure. We did a whole host of stakeholder meetings with different state agencies, municipal entities, our League of Minnesota Cities, and other groups to kind of find out what work they were doing in the space. In general, what we found is there was a lot of kind of siloed by infrastructure system data collection going on with very little goal setting of what's the goal for that infrastructure system. And then also a lot of risk analysis, but not really thinking through, because of the future weather changes, does that create opportunities to do things in a different way that we may not have identified before? So we created this sort of mapping lens to make sure to, suggest to agencies that they ought to be doing the kind of sets mapping of the infrastructure of the system they oversee, looking at risk and opportunities, but then setting integrated goals across agencies. And this we think will work well with because we have kind of resilient goal setting that's going on across our state agencies that MCAP is really facilitating through our pollution control. And we think this is a great tool to help them. We did kind of detailed sets analysis of different systems. This, I believe, is the water system analysis. We also looked at and said, if we start to map these systems in a similar methodology with similar data sets, we can start to look at goal setting and infrastructure planning across these different systems. So how does the watershed interact with the forest systems and agriculture systems in that area? So as we're setting a goal for adapting to future weather and flooding, we play out a whole series of maybe forest, ag, and watershed policy initiatives that we understand how they interplay together. And just one quick point, and we believe that that's important because the siloed approach is often coming up with the wrong solution, and maybe sometimes a very expensive solution to the challenges, or creating maladaptation in some cases we found. So the more we can have an integrated approach, we can get kind of the most cost-effective policy response and understand effects on other systems. So a little bit, and then I'll kind of bring it to an end and you can ask us questions. This is an example of some work that we're kind of in the middle of playing out now that's looking at an integrated across scales approach to water in our different watersheds. So what we're doing is we pick 9 site locations around the state, and we're mapping, we're taking that statewide precipitation data and looking at, given those increased rainfall amounts at particular sites where we would see bond projects, what do we see the effects of that data at the watershed scale, the kind of urban scale or town scale, depending upon where you are in the state, and then at the particular site scale, and how would an integrated set of policy guidelines play out where you're giving building projects, kind of urban water infrastructure projects, and watershed scale projects, an integrated set of guidelines to deal with that challenge. We're also mapping all these different locations, because some of the geographic differences in terms of elevation, slopes, the way the watershed works, what the soil conditions create different conditions or risks and opportunities given those increased precipitation levels. So there's some examples of this. And then very briefly, and I'll open it up to questions, we also did all this stuff with energy and ran energy models across the whole built environment in Minnesota, both residential and commercial buildings, and saw, in general, energy usage comes down because of the reduced heating loads, but electricity usage goes way up because of increased cooling loads. And so kind of figuring out in our energy system, how do we do load planning based upon future weather is going to be more and more important as we kind of integrate all this with our energy transition. So with that, that's the end, and went a little bit long, and I can stop sharing. And
Richard. All right, so any questions for Richard and team? Just raise your hand. All right, well then I'll get the ball rolling. Great work. I've been kind of following this work for quite some time. I think it's a really good example of what can happen at the state level, and depending on how things play out over the next few months, there might be more and more emphasis on kind of state level programs like this. I guess the question that I have is, it's very apparent that you were very much engaged with kind of the elected officials, county, state legislatures, et cetera. Did you have any, I know in the original questionnaire that was mentioned, you did have engagement with, some of the involved industries. What's the appetite for this information beyond the elected officials? Like, for example, here in Maine, building codes was actually on the ballot last fall. People are pushing back on building codes, claiming that, they raise the cost of housing, contribute to homelessness. I think there's a lot of misperception out there, but, it's one thing to have a friendly legislature or a friendly city county government, but how is industry reacting to this? Are you getting pushback on any of this?
Maybe I can start the answer. So there's quite a bit of push from private sector designers of different types, because they're getting our design community kind of works all over the country and world, and so they're getting requests for how to work with this kind of data, and the need for standards, because they're coming up with ways to work on it, but they feel like and there's a lot, as there's a lot of kind of beta level work going on in different pockets, and there's a real need to coordinate all that and roll it up into standards. The other factor is a lot of our owner entities are asking for this, not just our kind of 2 university systems, but big private sector owners are seeing subsets of the same things our capital construction group was seeing, and asking for, we need to be planning around this. So it's kind of popping up in all directions. And compared to other issues we're working on, or at least that I'm working on, which is the full array of things in sustainable building, I see probably the least pushback with this stuff.
Interesting.
Yeah, and even I mean, when it was discussed in our capital investment committee, we had both parties in support of this, and part of the discussion was they said we're not going to argue about why the changes are happening because we all agree that they're happening. So let's get to work.
All right, excellent. Okay, Norma Jean, I know you had your hand up first.
Thank you, Dan. I have a question for you. Well, actually, two questions. So you mentioned that you were seeing infrastructure damage to newly built infrastructure. So what kind of damage? And then the second question, because you might want to go, you might want to answer these flip-flopped in order, is you also mentioned that your infrastructure is not the traditional definition. So what did you incorporate? Because I can't remember who it was, but they mentioned forests and ag, and how did natural infrastructure, if that was the non-traditional infrastructure, just a little more detail.
Yeah. No, those are good questions. So it was an array of damage to projects. You know, I think in particular, a lot of building projects that didn't factor in localized flooding, they factor in riverine flooding of some kind. So some local, based on geography, watershed or water infrastructure in that particular place wasn't ready for the localized flooding impact. So that kind of thing happened. Many examples of our water treatment plants at the wrong elevations for things, which is requiring flood mitigation at certain times, but then in the drought times, we're using a lot of energy to treat water, because of that. So those are some examples, but it was really an array across infrastructure types. Trying to remember the second question. Remind me again the second question. Sorry.
Oh, the different types of non-traditional infrastructure.
Yeah. That was quite of a complicated question because there was this implication in the statute that we needed to factor in green infrastructure, but we did a literature review of what the definition of infrastructure was over the last, I think, 60 or 70 years in the Minnesota legislature. And we came back and found that there really wasn't a set definition. It just sort of moved around based upon what people wanted to fund. So we then, just to level set, created that kind of integrated green and gray infrastructure approach that we thought was important, and then kind of was something we could leverage in making policy advice. It does have this definition of infrastructure, as we've found, has a lot of implications on how you fund things. Because, for instance, we can fund green infrastructure in forests because it's in the Minnesota Constitution. But with building projects on a building site, the green infrastructure has to be tied to some building gray infrastructure thing. So that's kind of one of our next steps, is how does this play out from a funding standpoint?
All right, excellent. All right, I've got Joe Pica and then Joe Barsugli.
Yeah, thanks for going over this. My question is, it kind of goes on what Norma Jean said. There was some infrastructure that was damaged. I'm just wondering if there's been any type of economic analysis, kind of return on investment of, if they had done this, it would have saved this much in repairs, etc., so that there's an economic argument for pursuing this data and the better building codes.
Yeah, that's a really good question. And that is something I would love to track. And trying to track all cost data within our built environment is a political minefield that I have to navigate. And it's very hard to get these things to get really good data. Though we do have a bill in our current legislature that would allow us the sort of power to get all that stuff and depoliticize it a little bit because of the need to track it, or, you know, for cost effective investments. And that again is a sort of bipartisan thing. But yeah, that's a good question. I think we need to find another way to track the data, because it's rebuilding this is a significant impact. The effect, I mean, just the effect on, we do have really good data on, for instance, the increased energy usage in our water treatment plants managed by the state. It was the largest growing amount of our carbon emissions in operations because this wasn't factored in, which tells you potentially how significant it is in just annual kind of operating dollars. So,
excellent. All right, Joe Barsugli, take us home.
Yeah. So I have a couple of questions. Nice presentation, and I've been involved in the Western Water Assessment Climate Adaptation Program with NOAA as well here in Colorado. So interesting work. A couple questions. I remember I was at the Inspire conference at ASCE and talked to some highway engineers in like southern Minnesota, and there were a lot of damages to highways there as well. That same kind of surprise. I guess I want to point out that's actually adaptation to the current climate, not to the future climate. And the current climate has changed. I mean, this is the thing that we have to really recognize, is that if you're adapting to the climate of 1950, which often infrastructure was built or initiated then, that it's even just important to get the trends up till now correct. And as you point out, people see that happening. So that's a much easier, sell to it, because if they see things happening. What I wanted to ask though was, how is this, for example, the tool that was shown, and how is this being used? And what I mean by that is I've been involved in classic scenario planning. I've been involved in heavily system modeling intensive work with stakeholders. How does this get used? And just a couple examples might be nice. The actual climate and projection data.
Yeah, and I can, Amanda, do you want to take this and then I can pick up on it? Yeah,
I can too,
Happy
if you want.
Yeah, I guess, I mean, specifically to this project, for instance, our climate modeler, Stefan Lees, is working with HGA and CSBR and others to develop, using our future climate projections, future typical meteorological year files. And Ariane, that's probably what you're going to highlight as well. So we're really taking what we developed with the dynamical downscaling and then integrating or creating the types of data and future climate information that's needed for specific sorts of decision making. And so it really doesn't just stop with the public data that are available through the MinClimate tool. It's really taking that next step that we've been doing the work with CSBR and HGA to do.
We're also, in the meantime, taking the climate tool and training our colleagues about how, on how to do scenario planning with this projection data at a higher level. So it's not giving us the exact data formats that we're used to using in our tools yet, but what it is showing us is historic information compared to these future models, so we can see what the trends are showing and have conversations with our owners about what the potential impacts of that could be and what that range of future climates might look like. So there's a transition we're trying to push internally away from assuming stationarity of climate and weather information to what does it look like to think about non-stationarity as part of our practice. And we've also partnered with MCAP on doing NCSBR to do trainings targeted towards architects and engineers on scenario planning, essentially with the message that until the standards and building codes and updates have been made across our industries, we can have conversations with our owners about the potential impacts of these projections, because we're actually at greater liability risk if we don't.
Yeah, and we, in the report that we can also share, the legislative report, there were sort of use cases at the state policymaker level. So for instance, using a tool to do a scoring of bond proposal projects. So we assess how they sort of fit into the overall system, and are they making the system more resilient or not? We just do fiscal scoring now. So that was one of our recommendations. Then there's sort of all the kind of at the designer level use cases, whether it's energy or water, civil engineering, etc. But then there's also in the report a real need for kind of local, county and below resilience planning as their planning projects, because we have systems that might be part municipal, part county, part state funders in the overall system. So there's a local use case that we have tools that, you know, are translating the data to exactly what they need to be able to make some long-term planning decisions, and how, you know, if they're proposing a water treatment plant or water, you know, stormwater system, they have something where they can be looking at how that fits into the other scales of governance. Is another real need that we just, you know, identified, but more research is needed to tease those things out. So,
all right, excellent. Thank you so much.